Okay. What are the units of covariance for stocks? Units. Percent squared again. So it's often useful to have a unit-free measure of how things move together. What do we call that? What's the unit-free one?
Correlation.
Correlation. And what's the definition of correlation? Anybody know how we do that? Okay, so we've got the correlation of x and y. How we're going to write it often, you often see it written rho xy, and it's the covariance, and then we normalize by dividing by the standard deviation of x times the standard deviation of y. What's the range of correlations? The lowest? -1. That means that they move exactly opposite directions. And then at the other end, we've got +1. If two things are independent, what's the correlation? 0, yes. If we have a correlation of +0.5, what does that mean? It means most of the time they move together, but there's some independence where they move against each other. What's the evidence on stock returns? Well, we're going to be using two particularly important points. The first is the serial correlation. What serial correlation means is the correlation of stocks at date t, the stock return at date t with date t1, t+1. That's 0. So if stock returns were high this year, does that tell you anything about next year? No, it's 0. So that's the first important point. And then the second is, how do stocks tend to move within the day? Well, today's a good day on the stock market. What do you think the correlation of the stocks is? Positive. They tend to move together within the day. If we have a bad day, it's negative. The correlation of stocks within a period is positive. We're going to be building on that a lot. Okay, now, when you get further on in your statistics course, you'll start talking about regression. And what you do when you do a regression of y against x is you have the plot, and then you fit a line by least squares, as it's called. And in that case, we can work out the slope. Does anybody know what the formula for the estimate of the slope is? We're going to call that B star, and that's the covariance of y with x divided by the variance of x. What does that look a lot like? Where have we seen that today? Well, looking back to the beginning, that's the formula we had for beta. That was our beta return, beta measure. What we're doing there is we're doing a regression of the stock return against the market. And we've got that the slope is the beta. So one way of thinking about beta is it's the sensitivity of the stock return relative to the market. So for example, if we have a line with slope equal to 2, so the beta is 2, that means that for every 1% the market goes up, on average, what does the stock go up? 2%. If it has a beta of 1, it means every time the market goes up 1, on average the stock goes up 1. And then if we've got beta equals 0.5, what we've got is for the market going up 1%, the stock is going up how much? 0.5%. So that's another way of thinking about betas. It's a measure of sensitivity of the stock to the market. So, finally, let's think a little bit about diversification. This is the key idea that we're going to have in this part of the course. Let's think about it in very simple terms. Let's suppose we've got a stock, X1, and it's a very simple payoff structure. It's just like tossing a coin. We have a tail and a head. With a tail you get 0, with a head you get 2. The probability is 0.5, 0.5. What's the mean? Mean is going to be 1, half times 0 plus a half times 2. What's the variance? Work it out. It's 1, because the deviation from the mean here is -1. Square it is 1. Times a half is a half. Deviation from the mean here is 2 minus 1, which is 1. Square it, you get 1 times a half. Sum them up, you get 1. And so the standard deviation is 1. So this is a very simple situation.